So, Assalamualaikum and good evening, everyone. How are you guys today?
Waalaikumsalam. Good evening, teacher.
Waalaikumsalam,
I'm
teacher.
good, teacher.
So
How about you?
good. I'm good too. So I hope you guys are doing fine and okay as we still in pandemic situations. So I hope you guys can take care of yourself and stay safe, okay?
Okay, teacher.
You too.
So welcome back to my Addmaths class for today. So are you guys ready for our class today?
Yes, I'm
Yes,
ready,
teacher.
teacher.
Right. First and foremost, I'm going to go through our learning outcome first. So at the end of this topic, students should be able to differentiate which one is indefinite integral and definite integral. And also students should be able to find the area under the curve which includes or bounded by x-axis or y-axis using integration method which is definite integral, and able to state the integral value whether it's positive or negative if the region is below or above x-axis, or if the region is to the left or to the right y-axis, okay? Before we start our lesson today, let's recap last week's lesson that we had learned last week. So, anyone can answer this. How to write the definite integral of a function fx with respect to x with the interval from x equal to a to x equal to b? Anyone? Are you guys still remember last week's lesson, which is definite integral?
Yes.
So how we want to write the definite integrals?
You put integral, and then there is a lower limit a,
Okay, limit
and
a,
then upper limit b,
and
then function fx and
right,
dx.
the x. Correct. So this is how you want to write the definite integral. So next, so which one is the indefinite integral or definite integral?
One is the indefinite.
So this one is?
Indefinite.
Yes, correct, Yana. And the other one is definite integral. So how we want to know the difference between indefinite integral versus definite integrals?
For definite, there is a limit.
Yes, correct. For definite integral, you have limit a to b fx to respect of x. For indefinite integral, it does not have any limit. It just like the basic integrations. So fx respect to x. That's the difference between indefinite and definite. So for example, for indefinite integral, like x cubed over dx, how you want to integrate this function?
X to the power of 4
Yes.
divided by 4
Plus C.
Yes. For indefinite integral, you have to put plus c. Okay. But for definite integral, we do not have to put the plus c. Okay. So let's see example for definite integrals. So how to calculate this function? Anyone?
X to the power of 3
Over.
divided by over 3.
And then you have to put bracket first.
Bracket.
And then put the limit. Right?
Yes.
So, and then you can just substitute the limit in the x. 3 cubed over 3 minus 2 cubed over 3. So you will, what you get? What the answer? Anyone?
9.
6.33, teacher. Is it correct?
Yes. 19 over 3 or 6.33. That's correct. So I would like to ask, which one is our upper limit and which one is our lower limit?
2
3
is
is
lower
upper
limit.
limit.
Yes, 2 is our lower limit and 3 is our,
Upper limit.
yes, correct. So I hope you can know which one is lower limit and which one our upper limit, okay? And know how to integrate the functions. So next, we go to our lesson today. We proceed to our lesson today, which is area under the curve. Are you guys ready?
Yes, teacher.
Yes, teacher.
So area under the curve, there are two types, which is bounded by x-axis and the other one is bounded by y-axis. So this is the graph that you can see in front of you. Can you see?
Yes.
Okay, right. So let's we proceed to the first one, which is bounded by x-axis. Okay, so the first one is area under a curve that bounded to x-axis. So to find the area, we will use definite integrals. Like just now, we recapped. So for example 1, find the area of the following shaded regions. So this is our diagrams. So any idea how to find the area of the shaded region?
First, we need to know the limit.
Yes, you have to know the limits. So this is our lower limit and this is our upper limit. So first we have to write the definite integral of a function, which is
2x square. Y.
yes, y respect to dx first. So our lower limit is 3 and the upper limit is 6.
2, 6.
So we substitute the value of y. So you will get 2x squared dx. And then you can just integrate like usual. So you will get what? 2x cubed over 3, close bracket, and put the limit outside the
6.
bracket. And you can just substitute the upper limit and lower limit in the function that you integrate just now. What you get? The answer. So when you calculate, you will get 126. So you can just put units square. So as it is area, so you have to put unit square. So, okay, this is how you want to calculate the area under the curve that bounded to x-axis. Okay, next, I would like to ask, what happened when the region is below the x-axis?
The
This
value
is-
will become negative.
Yes, correct. The value will become negative. So please bear in mind that if the region is below the x-axis, then the integral value is negative. And if the region is above the x-axis, then the integral value is positive. So when the area of both regions are positive, so when you add on the area of the both regions, you will get positive. So I hope you can remember this, okay?
Okay, teacher.
Yeah.
Okay, next we'll go to example 2. Before that, how we want to calculate when we combine the shaded region above and below the x-axis?
We need to make a two integral.
Yes, we have to separate the regions first. So first, let A be the area of the shaded region below the x-axis, and let A be the area of the shaded region below the x-axis, and B be the area of the shaded region above the x-axis. Okay, so we are going to find the area of the region A first. So now what to do?
Set up the integral.
Yes, correct, Yana. We have to set up the definite integral of function y with respect to x. So our lower limit for region A is
0 to 3.
0.
yes,
3.
correct. And then function of y with respect of x, and then you just substitute y, the function y, which is 2x squared minus negative minus 6x. 2x squared minus 6x dx, and then you just can integrate. You will get 2
X
x
cube
cubed over 3
over 3
minus
minus 6 x square
x squared over
over
2,
2.
close the bracket and put the
0 to
limit.
3.
So you can just substitute the upper limit and lower limit. So 2 times 3 cube over 3 minus 6 3 square over 2. So minus 0. So if you substitute 0 in the x, you will get 0. So the answer you will get,
Is it negative 9?
yes, correct Nisa, negative 9. So, okay, like I said before, the negative side is when the region is below the x-axis. So the negative side of the value of the definite integral is only to indicate that the area is under the x-axis. So the negative side can be ignored for its area. So hence, the area of the region is 9 units square. So you can just ignore the negative side. It just indicates that the area is under the x-axis, okay? Okay, students?
Okay, teacher.
Okay.
Teacher.
So next we go to find the area of region B. Just now we had just find the region A, now region B. So what we want to do first, we have to set up the definite integral of functions. What is the lower limit?
3.
3 to 6.
And upper limit is 6.
Yes. The function
Y
of
and
y dx. And then substitute y with the functions 2x squared minus 6x dx. And then you just integrate like usual. You will get 2x
2x
cubed
to the power of
of
3 divided by
minus
minus 6x squared
6x squared over 2.
over 2.
Close bracket
3
and put the limit.
to
3 and 6. So the difference between region A and region B is only the limits. So you can just substitute the upper limit minus with the lower limit. So what you will get, students? So you will get 45 since, so the area of region B is 45
45.
units square. Okay, so that's area of the region B, and then you just can sum up or total up the area of the shaded regions. So the total area wait for a while. So the total area of the shaded region? Anyone can answer?
9 plus 45
9 plus 45 equal to
equal to 54
54.
unit square.
unit square.
Unit square. Right. So there is the alternative method you can use. Area of the shaded region, you just can use, you just write like usual, but make sure to put modulus at the area or regions that below the x-axis. So there is a modulus. So you will get 9. So from negative, you become positive. So that is the alternative method. Okay. Now let's learn how to find area under a curve that pointed to y-axis. So before we go to the first example, I would like to ask, if the region is to the left of y-axis, then what is the integral value, whether it's positive or negative?
Negative.
Positive.
Yes, correct. It will be negative. So this is to the left. So this is to the right. So if the region is to the left of y-axis, then the integral value is negative. And if the region is to the right of y-axis, then the integral value is positive. And then the area of both regions, when you combine, will become positive. So I hope you can remember this, okay?
Okay, teacher.
Okay, teacher.
Let's do the first example. This is our first example. Given the functions of the curve is y squared equal to negative x. So since we want to find the area under the curve that pointed to y-axis, so the function must respect to y, right?
Yes.
The function must respect to y. Just now, that pointed to x-axis, it respect to
X.
X.
Yes.
yes, correct. So we use this. So then, but we have to express the function in terms of y. X equal to negative
Negative
y,
y squared.
y squared. That's correct. So how you want to calculate or to find the area of the following shaded regions? First, you have to set up the definite integral of the functions x with respect to y. So what is our lower limit?
0.
Are you sure?
1.
Yes, correct. 1 and
And
the
upper
upper
limit is
limit
4.
4. So the function of x with respect to y. And then substitute x with our functions, which is negative y squared dy. And then you integrate like usual, so it will get in bracket negative
Negative y to the power of 3 divided by 3.
3 close bracket and then
Close
you put
bracket.
1 to
1 to 4.
4. And then you just substitute the upper limit and minus the lower limit. Okay. So minus will become positive.
Positive.
So 1 to the power of 3 over 3. So the answer will
Negative 21.
negative 21. So like I said before, the negative side of the value of the definite integral is only used to indicate that the area is to the left of y-axis. So the negative side can be known for its area, okay? So you can just conclude that the area of the shaded region is
21
yes,
unit square.
correct. 21 unit square. Let's do the last example for today, which is example 2. This is the combinations from of left and right. So the diagram show a part of the curve which is x equal to y negative 2, y minus 5. Find the area of the following shaded regions. So as you can see in diagram, what you feel? You will feel curious about where do they intersect with the y-axis, right? Because there is no value of y
Yes.
intercept. So in order to find the intersections, we will let x equal to 0. Okay? When we want to find y intercept, we will let x equal to 0. So y minus 2 bracket y minus 5. So you will get y equal to 0, then
2.
y equal to
Y
2,
equal to 2 and y equal to 5.
5. Yes, correct, Adira. So those are the y-intercept where you can plug in. Wait for a second. So first is 0, and then 2,
2,
and then
5.
5. Yes, correct. So that's how you want to find the y-intercept if they did not give any y value. So now we are going to find area under the curve from 0 to 2 and 2 to 5. So first we have to separate two regions because the other one is positive and the other one is negative. So the region A is bounded by y equal to 0 and y equal to
2.
and region B is bounded by y equal to 2 and y equal to
5.
So let A be the area of the region to the right of the y-axis and B the area of the regions to the left of the y-axis. So, but you do not to forget to expand your function, so it is easier for us to do the integration to find the area under the curve. So we have to expand first the bracket behind. So what we will get y square minus 5y minus,
2y
and then
plus 10.
plus 10, and then you times with y at the front, you will get y cube
Y cube minus
Negative
7 minus 7y square
square
okay
plus 10y.
plus 10. Right, so you have expand the functions. Now we're going to find the area of region A. So what we have to do first?
set up the integral.
Yes. So what is our upper limit and lower limit?
0 to
0
2.
and 2.
2 function of x respect of y
dy
Y
and then you just substitute the functions of x. We will get
y
y
cube
cube
minus
7y
7y
square
plus
plus
10y
10y. D?
Respect
dy.
to y.
Yes, correct. Integrate first, you will get
y
Y to the power of 4
4 over 4
divided by
minus
minus
7
Y
7
cube
y
over
cube
3
over 3
and then
plus
plus
10
y square
y
over
square
2.
over 2.
yes, correct. Thank you, student. And then close the bracket, put the limit 0 to 2. And then you can just substitute the upper limit minus with lower limit. And what you will get, students, take your time to calculate it. Anyone? You will get 60 over 3. Is it correct?
Yes,
Yes, teacher.
So the area of the region A is 16 over 3.
unit cube,
Unit
square.
square, yes. So next we find area of the region B. Like usual, you just write the definite integral functions 2 to 5, then x with respect of y, and then you substitute the function x in terms of y, which is y cube minus 7
y
y square
plus
plus 10
y
y d.
dy.
So when you integrate, you will get the same as a at the a, which is y to the power of 4 over 4 minus 7
7y cube over
over
3
3
plus 10y
10
10y square over 2.
over
2.
2. So write the upper and lower limits. Okay, don't forget to write. So you substitute the upper limit minus with lower limit. What you will get, students? Since the area of the region B is to the left of the y-axis, you will get negative. And then the answer will be 63 over 4. Okay, so like I said before, the negative side is just to indicate that the region is to the left of the y-axis. And you can just ignore when you do the conclusions. Okay, so the total area of the shaded region, can you calculate, student? 16 over 3 plus
63
negative 63 over 4. What you will get, students?
Teacher,
Yes?
do we need to include the negative sign?
Yes.
Yes.
Did not have to include the negative side. Thank you, Nadira.
Okay, teacher.
It shows you that you focus in my class. So what the answer? 2
253
over?
over 12.
over 12.
Yes, correct. So the answer is 253 over 12, the total area of the shaded region. Well, that's all for our example today. So the conclusion is, first you have to know the difference between indefinite integral and also definite integrals. And the second one is that there are two types of area under a curve, which is bonded to x-axis and bonded to y-axis.
Y-axis.
So and then you should know the integral value. If the region is above x-axis, so the integral value will be positive.
Positive.
If the region is below x-axis, will be negative.
Negative.
And the region is to the left of y-axis,
Become negative.
sorry, will become negative. Okay, to the right of y-axis will become
Positive.
So I hope you guys can understand our topic for today. So before we end our class today, we are going to do a simple quiz or game using Miro applications. So I will give to you the link. So I will stop the sharing first, okay?
Okay,
Okay,
teacher.
teacher.
Can you see what I present now?
Yes, I can see.
Yes, I can see, teacher.
Okay. There are 3 students. Okay. So the rule is you have to drag in which one is the correct answer at each table. Okay. I give you like 2 minutes. It's just a simple game or simple quiz now. So you can start now. You guys okay, students?
Okay, teacher.
Okay, good. So the table at the area of the region between the curve and the y-axis is finished. Okay. So I think that's all, right?
Yes, we are done.
So this is correct. So the region is above the x-axis, correct. So the upper and lower limit is 0 to 3. Y to the respect of x, correct. And then you substitute y, you'll get this. And then you integrate the functions, you will get this. And just substitute the upper limit and the lower limit, you will get the allocation region is 21/2 unit square, correct. So the next one is between the curve and the y-axis, region between the curve and the y-axis. The region is to the left of the y-axis, correct. And the lower limit is -2 to 1 at respect of y, and substitute in terms of y, dy, and then just integrate like usual, and we'll get -33/2. But like I said before, you do not have to put negative side. Okay, you can just ignore. Okay, I think that's all for our today class. I hope you can understand our lesson for today. Okay, students. So that's all for today class. Thank you, students, by taking part in my class today. Thank you, students. Stay
Welcome,
safe
teacher.
and see you again. Bye.
See you again, teacher. Bye.
Bye, teacher. Thank you.